Today, we're taking a deep dive into one of America's most iconic landscapes, Yellowstone National Park. But we're not just here to talk about geysers and bison. We're going way, way back in time to uncover the explosive story hidden beneath all that beauty. I'm talking about a volcanic history that's been brewing for over 16 million years. Forget what you see on the surface. The real action is underground. So, let's start with a big question. Is Yellowstone a volcano? Yes, and it's not just any volcano, it's a supervolcano. But it doesn't look like the classic cone-shaped mountain you might be picturing, like Mount Fuji or Mount St. Helens. Instead, Yellowstone is what geologists call a caldera. Imagine a massive underground chamber of magma. When it erupts, it's so powerful that the ground above it collapses, leaving a giant sunken crater. That crater is the caldera. The one we see today is huge, roughly 30 by 45 miles. But this whole story didn't start in Wyoming. It began about 16.5 million years ago, way over in what is now the border region of Oregon, Nevada, and Idaho. This is where the Yellowstone hotspot first made its grand entrance. Now, what's a hotspot? Think of it like a giant blowtorch deep within the Earth's mantle, a stationary plume of superheated rock that punches its way up through the crust. It's completely independent of the moving tectonic plates that make up the Earth's surface. Picture this. The North American plate is slowly but surely crawling southwest over this fixed hotspot. It's like moving a piece of paper over a lit candle. As the plate drifts, the hotspot burns a series of volcanic scars across the landscape. This trail of ancient calderas, stretching from Oregon to Wyoming, is known as the Snake River Plain. So all those flat volcanic plains in Idaho? They're basically the older siblings of Yellowstone, a breadcrumb trail leading us right to where the action is today. The first major super-eruption linked to this hotspot was absolutely colossal. It created a feature called the McDermott Volcanic Field on the Nevada-Oregon border. We're talking about an event that would make modern volcanic eruptions look like firecrackers. It blasted out thousands of times more material than the 1980 eruption of Mount St. Helens. This set the stage for a long and dramatic history of volcanic activity as the North American plate continued its slow-motion journey. The hotspot stayed put, and a series of massive eruptions followed. It's like the hotspot was a serial volcano builder, creating one caldera after another. Over millions of years, this process repeated, leaving a chain of volcanic depressions across southern Idaho. Geologists have identified at least a dozen of these super-eruptions along the hotspot track. Each one was a cataclysmic event that reshaped the continent and likely had global effects on the climate. Now let's fast forward to what we think of as Yellowstone proper. The hotspot finally reached northwestern Wyoming around 2.1 million years ago, and it announced its arrival with a bang. This was the Huckleberry Ridge Tuff eruption, one of the largest volcanic eruptions known to science. It was truly mind-boggling in scale. The eruption spewed out about 6,000 times more ash than Mount St. Helens. It formed a caldera so vast that it covered most of what is now the national park. The ash from this single event has been found as far away as California, Louisiana, and even into Canada. Can you imagine the sky turning dark across an entire continent? It would have been an apocalypse for any life caught in its path, but the hotspot wasn't done yet. After the Huckleberry Ridge eruption, things quieted down for a bit, geologically speaking. The magma chamber slowly began to recharge, like a battery powering up for its next big show. Then, around 1.3 million years ago, another super-eruption occurred. This one, known as the Mesa Falls Tuff eruption, was smaller than the first, but still enormous by any human standard. It created another large caldera within the park, near the area of Island Park. While not as big as its predecessor, it was still a powerful event that left its mark on the landscape, and that brings us to the most recent super-eruption, the one that shaped the Yellowstone we know and love today. About 640,000 years ago, the Lava Creek Tuff eruption took place. This is the eruption that formed the current Yellowstone caldera. It was smaller than the Huckleberry Ridge event, but still twice as large as the Mesa Falls eruption. It blasted out enough rock and ash to bury a state like Texas several inches deep. The collapse of the ground following this eruption created the vast, bowl-shaped depression that contains Yellowstone Lake and the famous geyser basins. So, when you're standing at Old Faithful, you're literally standing inside an active supervolcano that has a long history of blowing its top in spectacular fashion. Since that last big eruption 640,000 years ago, there have been dozens of smaller but still significant lava flows. The most recent of these occurred about 70,000 years ago. These flows are what have filled in parts of the caldera, creating the rolling hills and plateaus you see today, like the Pitchstone Plateau. This is why Yellowstone is so geothermally active. The magma chamber that fueled those ancient super-eruptions is still there, just a few miles beneath your feet. It's not as full as it was before the last eruption, but it's still incredibly hot. This heat is what powers everything from the geysers and hot springs to the bubbling mud pots. Rainwater and snowmelt seep deep into the ground, get superheated by the magma chamber's energy, and then race back to the surface, creating those amazing geothermal features. Yellowstone has more than 10,000 of them. That's over half of the world's total. So the big question on everyone's mind, is it going to erupt again? The short answer is yes, eventually. But eventually in geologic time is very different from our human concept of time. Scientists at the Yellowstone Volcano Observatory monitor the volcano 24/7, tracking everything from ground uplift and seismic activity to gas emissions. They say there are no signs that a super-eruption is imminent. The most likely volcanic activity in our lifetimes would be a much smaller lava flow or a hydrothermal explosion, which is like a geyser erupting with rocks and steam. The average time between Yellowstone's 3 major super-eruptions is about 725,000 years. Since the last one was 640,000 years ago, some people get worried by the math. But volcanoes don't run on a strict schedule. It's not overdue. It could be thousands or even tens of thousands of years before anything major happens. Or it's possible the hotspot is starting to wane in its intensity and might not produce another super-eruption at all. We just don't know for sure. What we do know is that the 16-million-year journey of the Yellowstone hotspot has created one of the most dynamic and fascinating geological areas on the planet. From its origins in Oregon to its current home in Wyoming, this relentless force of nature has sculpted the American West. The next time you see a picture of Yellowstone, don't just see the beautiful forests and amazing wildlife. See it for what it truly is. The latest chapter in an epic ongoing story of fire and earth, a story written across millions of years and hundreds of miles. Thanks so much for joining me on this journey through geologic time. It's pretty wild to think about the incredible forces at play right under our feet. If you found this as fascinating as I do, be sure to hit that like button and subscribe for more deep dives into the wonders of our world. Drop a comment below with any questions you have, and I'll see you in the next video.